as mentioned, I'm not done with my zinc oxide. I'm going to give it one last final college try. I spent some time looking at the literature, which I know I shouldn't have done, but did it anyway. And they say I need to put this stuff in a retort to smelt it. Well, here's a retort. A retort, strictly speaking, is any airtight vessel that you place a chemical compound in so that you can heat it and drive off gaseous elements for further processing. So, that's a retort. Now what it says you're supposed to do is put this stuff in your retort with carbon, and then you need to heat it. You need to heat it pretty hot. It's variously listed as either 1,000 to 1,400 degrees C in order to essentially drive the zinc off. And since that's much higher than the melting point of zinc, what you have to do then is catch it in a condenser. You're essentially going to distill the zinc oxide or the zinc off and then collect it using a condenser, just like you were doing this as a chemistry project. So essentially what I have here is my smelting chamber, which goes in my heat source, and then this tube is my condenser, which needs to be cooler obviously than 1,000 degrees C. It's probably cool enough just getting it out of the flame, but I could also put it in a water bath or something. Okay, so that's my setup. One other style point: the resemblance of this device to a pipe bomb is both unintentional and scarily possible. So one thing I did do was put a relief valve in this device, or a relief hole. Say this thing actually did drive zinc off and it collected in this, it's at least theoretically possible that it could build up enough to close off this tube, in which case I've got a pipe bomb. And even though the exploding balls looked fun, I don't think this thing exploding would be fun. So two thoughts on that. The first thing is I'm not going to screw these things so tight that they can't leak at least a little bit. And then I open this hole up and I figure I can just take this chunk of a nail, which is very loose in the hole, and just put it in like that. It's made of steel, so it should survive, and all that is intended for is if this thing tries to get loose, this thing will just pop out and I won't wind up dead. I swear, I'm swearing to you, there is no explosive intent here. Do not censor me for content. This is all about chemistry, not about explosions. It's also about being really safe while we're doing this stuff. Time to put her on the cooker. This is it. If this doesn't work, I'm done with zinc. Since I'm in a melting mood, if you will, I've been thinking about those exploding balls and the fact that I did manage to melt that ore, which is essentially rock. So the question comes up, came out kind of glassy. Of course, that word got my attention. So what happens if I try to melt this? Let's just put some of this in there. So I don't know if you guys have ever heard of soda lime glass before, but it's a very early form of glass made of sand, soda, which is sodium carbonate, and lime. And as far as I can tell, a little confusing whether the lime is calcium carbonate or calcium hydroxide. I don't know that it necessarily matters which one is which. I'm going to use calcium hydroxide. I can always slip back to calcium carbonate because that's what my eggshells are. But let's just try this. So I need That's 73 grams of sand. The sodium carbonate is a flux, which makes the sand melt at a lower temperature. And then the lime is a stabilizer so that the newly formed glass won't be attacked by water and rain and so on. I'm going to go up to 100 for a total of, so that's 73, 15, and 12% respectively by weight. Because I don't know much about my temperature control, I got me a little bitty baby crucible that I'm going to melt this stuff in. Thank you, Jeff, once again. And I'm not planning on producing optical quality glass. I just want to see what happens. Which is a good thing I'm not planning on producing optical quality glass, because that ain't happening. The real question is if I can produce glass at all. Just as an FYI, that's a couple or 3 weeks after I planted them. Everything is growing great. Even my chilies look okay. That is Rose Campion. It's just going gangbusters. It's really beautiful. Highly recommended if you're looking for a biennial that will aggressively reseed. It's a pretty plant. But to the business at hand, a silly work thing came up, so I'm a little behind the 8 ball on time, particularly because I want to let this stuff rip for a while. So I'm going to bake my zinc with the I'm going to put the glass in there too, which was not what I intended. I intended to bake them separately, but darn work, I don't have time. I need more heat for the zinc than I need for the glass. I need about, as we said, I think I said I need 1,000 to 1,400 Celsius for the zinc, and for the glass I only need in the range of 800 or 900 to get it going. It's different when it comes to actually forming glass and blowing it and that sort of stuff, but I ought to be able to get it to at least melt at 800 or 900 degrees, and that's clearly within my capabilities. So I'll do both of them at the same time. We'll just see what happens here. That's my cooking vessel. You can see my condenser there. I'm going to just go ahead and put some water in here. Iron's not a very good conductor of heat. I think it's absolutely possible that that thing could get really, really hot without this getting really, really hot. But if that's producing vapor, which is boiling off, then this thing should get pretty hot. So my thought is, if that water starts to heat up, I'm probably pushing vapor off of that vessel there. So we'll let this baby rip for a while and see what happens. 4 minutes. I'm getting something out of that condenser pipe. I got no idea what it is, but keep watching it and see what's up. Look at that, 6 minutes in, and the stuff coming out of that tube is caught on fire. I have no idea what that might be. 20 minutes into it, and doggone it, look at the top of that elbow there. There's zinc oxide on it. So again, something's fricking failed. This is killing me. I'm never doing this again. Well, we're at 28 minutes. I'm just going to go ahead and let it burn itself out. No fire out of the tube anymore. Lots of zinc oxide still coming out. I don't understand why it's coming out that little hole when the big hole up at the top is available. Maybe the elbow got occluded somehow. So maybe my safety valve is doing its thing. I'm going to let this thing burn out, and then we'll see what we got. Here's the results of my smelt. I haven't opened this yet. I don't know what's in it. We'll find out together. As you can see, I've managed to toast this thing pretty effectively. So, people refer to black pipe as black iron pipe. It's not really iron, it's actually a form of mild steel. So, this is a burned up mild steel pipe. Mild steel melts at 1300 to 1350 degrees Celsius. And if you look, I melted it. Look at that. This is not like a softened. It melted and ran. So that's encouraging. It means things got pretty hot. Remember the way this was sitting in there, the air was coming in from this way. So interestingly, at maximum heat was not at the air. It was just kind of over by the air. So popping this open, I often use the terms like tremendously satisfying, but this is more than tremendously satisfying. This is validation. I've been working my ass off on this, and I've finally smelted zinc out of zinc oxide. Can you see in there? Look at that. That is zinc, which has condensed around the sides of that pipe. And this has a chunk of zinc in it. That is tremendously gratifying. I finally did this. I didn't want to produce quantities of zinc. I just wanted to take that stuff from goop and turn it into metal, and I finally did it. Now I can rest easy. I can rest assured. I don't have to do this again. Lots and lots of zinc. I figured out how to make zinc metal out of zinc oxide. Yes, it cost me the ultimate price. I had to read the literature, but I did do it. Let's turn our attention to the glass. So I started with this, and I put it in that cute little graphite crucible, which luckily didn't cost me very much money. I paid $8.98 for it because, it was rated to withstand a tremendous amount of heat, but what it wasn't really rated for was to be like thrown into a fire. Because graphite is combustible, and sure enough, if it didn't burn the thing, the top is gone. And as you can see, this thing is pretty well eaten away. So it says it's rated to withstand extremely high temperatures like 1300 degrees Celsius, but that doesn't mean it's intended to be dunked into flame. I think a lot of people use these things in electric furnaces. So you can see it's pretty well eaten away there. I don't know what this is. I truly don't know what this is. I mean, it's not glass, but it's not sand either. So I clearly was able to fuse this stuff into something. I just don't know what it is. And the fact I was able to do anything with it encourages me that I can do more with it. So we'll think about that in the future. So I think we'll wrap this particular episode up. Hope you'll like and subscribe, tell your friends, learn a little bit more about melting. We'll get back to the bathroom here in an upcoming episode. See you later. Thank you.